For nearly 5 decades, humanity has gazed into the vast expanse of space, convinced that the edge of our solar system, a region known as the heliopause, marked a desolate boundary. We imagined it as a silent, cold frontier where the sun's influence wanes, giving way to the faint hum of the galaxy. This perception, rooted in decades of scientific consensus, painted the heliopause as an empty void, a passive transition into the interstellar medium. Yet, Voyager 1, a spacecraft launched in 1977, has shattered this illusion with revelations that challenge our understanding of the cosmos. Now, more than 45 years into its mission and over 24 billion kilometers from Earth, Voyager 1 has detected an anomaly, a structured, repeating signal that defies explanation. This is not a planet, a star, or a stray signal from Earth. It is a ripple at the edge of everything we thought we knew, whispering a message that may redefine our place in the universe. Voyager 1, a messenger beyond the solar frontier. Launched on September 5, 1977, Voyager 1 was designed as a testament to human ingenuity, a scout to explore the outer planets, and, ultimately, the unknown reaches of interstellar space. Equipped with a suite of instruments to study magnetic fields, cosmic rays, and plasma, it captured iconic images of Jupiter's turbulent storms and Saturn's majestic rings, etching its place in history. After completing its primary mission, Voyager 1 continued its journey, propelled by a nuclear-powered radioisotope thermoelectric generator. In 2012, it achieved a historic milestone, crossing the heliopause, the boundary where the sun's magnetic field and solar wind yield to the interstellar medium. Scientists anticipated that beyond this threshold, Voyager 1 would encounter a tranquil void, a slow fade into cosmic silence. Instead, the spacecraft began detecting something extraordinary: magnetic ripples, vibrations in the radiation field, and, most recently, structured pulses that hint at a cosmos far more dynamic and complex than we ever imagined. The heliopause, once thought to be a protective shield against galactic cosmic rays, is now revealing itself as a contested frontier. Voyager 1's instruments, though aged and limited, have recorded fluctuations that defy conventional models of interstellar space. These disturbances are not random. They exhibit patterns, repeating signals, energy shifts, and distortions in time-based telemetry that suggest the presence of an organized phenomenon. Some scientists speculate that these anomalies resemble echoes bouncing off an invisible structure, raising a chilling possibility. Voyager 1 may not be alone in this distant realm. The spacecraft, designed to listen, might now be listened to, its faint signals intercepted by forces or systems beyond our comprehension. A cosmic web, the interstellar current hypothesis. The anomalies detected by Voyager 1 have prompted researchers to reconsider the nature of interstellar space. Far from an empty wilderness, the galaxy may be a vast network of energy currents, cosmic arteries threading through the stars, invisible to our telescopes, but palpable to sensitive instruments like those aboard Voyager 1. This emerging hypothesis, supported by recent data, suggests that the spacecraft has stumbled into an interstellar current, a dynamic force that connects solar systems, channels energy, and, potentially, carries signals. These signals may not be natural phenomena, but intentional transmissions encoded within the fabric of the cosmos. If this theory holds, the heliopause is not merely a scientific boundary, but a checkpoint, a region where unseen forces monitor, filter, or even regulate passage. The structured pulses detected by Voyager 1, characterized by a rhythmic consistency too precise for cosmic noise, lend credence to this idea. These pulses, first identified in telemetry data in the early 2020s, and intensifying through 2025, follow a pattern that aligns with Earth's position relative to the galactic center. This correlation is unsettling as it suggests that the signals are either tracking our planet or responding to Voyager's presence. The implications are profound. The edge of our solar system may be a gateway, and Voyager 1 may have inadvertently crossed a threshold into a domain governed by rules we do not yet understand. The architect hypothesis: engineered zones in the galaxy. As conventional models struggle to explain Voyager 1's findings, a radical idea has gained traction among astrophysicists: the architect hypothesis. This theory posits that the galaxy contains engineered regions, vast structures or zones created by an ancient, advanced intelligence. Rather than a chaotic wilderness, space may be a partially constructed environment with mechanisms that have operated for billions of years. Voyager 1's readings, magnetic distortions, gravity anomalies, and rhythmic pulses align with predictions made by proponents of this hypothesis, who argue that such phenomena could indicate proximity to a controlled interstellar system. The architect hypothesis challenges the assumption that the cosmos is purely natural. Instead, it envisions a galaxy laced with infrastructure, energy grids, communication networks, or even gateways designed to serve purposes we cannot fathom. Voyager 1's detection of low-frequency pulses embedded deep within the noise floor of its telemetry supports this view. These pulses, which flare up and vanish at precise intervals, were initially dismissed as static, but have since been mapped to reveal a structured rhythm. Their alignment with Earth's galactic position raises questions about whether Voyager 1 has entered a region designed to monitor or interact with passing objects. If true, the spacecraft may be skimming the edge of an ancient mechanism, still operational after eons, its purpose obscured by the vastness of time. The golden record, a beacon, or a trigger? When Voyager 1 was launched, it carried a message to the stars. The golden record, a gold-plated disc containing sounds, languages, music, and images from Earth. Intended as a greeting to any extraterrestrial civilization that might encounter it, the record was a symbol of humanity's curiosity and hope. However, recent speculations suggest that the golden record may be more than a passive message. Its electromagnetic signature, derived from its materials, spin, and frequency, could function as a beacon or tag, identifiable by advanced systems. If Voyager 1 has entered an engineered zone, the record's unique properties might have triggered a response, activating a mechanism that was lying dormant until a signal of intent was detected. This possibility raises a haunting question. What if the golden record was not just a message, but a key? The structured pulses detected by Voyager 1 could be the result of an external system recognizing the record's signature and initiating communication or surveillance. The spacecraft's recent anomalies, including signs of external modulation in its signal structure, suggest that its hardware may be influenced by forces beyond its design. Voyager 1, built to transmit data back to Earth, might now be functioning as a relay or node in a larger network, its signals repurposed for purposes we cannot discern. The golden record, once a gesture of goodwill, may have inadvertently announced our presence to a cosmos that was already listening. A signal from beyond, natural or intentional. The most perplexing aspect of Voyager 1's discoveries is the nature of the repeating pulse it has detected. Far too consistent to be random noise, this signal originates from beyond the heliopause, ruling out the sun or any known terrestrial source. Scientists are divided on its origin. Some argue it is a natural phenomenon, a previously unknown property of the interstellar medium, perhaps related to plasma waves or magnetic field interactions. Others, however, propose a bolder explanation. The pulse could be an intentional signal, a galactic broadcast that Voyager 1 has inadvertently tuned into. This idea, while speculative, is grounded in the data. The pulse's rhythmic structure and its correlation with Earth's galactic position suggest a level of organization that is difficult to attribute to chance. Some physicists have likened Voyager 1 to a lost antenna, its aging instruments accidentally aligning with a cosmic frequency. If this is the case, the spacecraft may be picking up a signal that was never meant for us, but is now audible due to its prolonged exposure to the interstellar environment. The question remains, are we the only ones hearing this broadcast, or are we merely the latest to detect a signal that has been active for millennia? Voyager 1's transformation. From scout to cosmic relay. Voyager 1 was built as a human creation, a machine to carry our story into the stars. Yet, at 24 billion kilometers from home, it may no longer serve that purpose. The anomalies in its signal structure, external modulation, frequency shifts, and telemetry distortions suggest that the spacecraft is being influenced by an outside force. Its instruments, though not designed for interstellar decoding, are picking up patterns that hint at reprogramming or repurposing. Voyager 1 may now be part of a larger system, its signals integrated into a network we cannot see or understand. This possibility challenges our perception of Voyager 1 as a solitary explorer. Instead of a message in a bottle, it may have become a node in a cosmic web, transmitting data not to Earth but to an unknown recipient. The implications are staggering. If Voyager 1 is acting as a relay, what is it communicating, and to whom? The spacecraft's limited power supply, expected to dwindle by 2026, adds urgency to these questions. As its instruments fade, we may lose our only window into this enigmatic phenomenon, leaving us with more questions than answers. The broader context, humanity's place in the cosmos, Voyager 1's discoveries come at a time when humanity is reevaluating its place in the universe. Advances in astronomy, such as the James Webb Space Telescope's observations of distant galaxies and the detection of exoplanets with potential biosignatures, have expanded our understanding of the cosmos. Meanwhile, breakthroughs in artificial intelligence and signal processing have enabled scientists to reanalyze Voyager's data with unprecedented precision, uncovering patterns that were previously overlooked. These developments, combined with Voyager 1's anomalies, suggest that we are on the cusp of a paradigm shift, one that could redefine our relationship with the galaxy. The structured pulses and magnetic ripples detected by Voyager resonate with emerging theories about the universe's complexity. For instance, recent studies of galactic magnetic fields, published in journals like the Astrophysical Journal in 2024, propose that the interstellar medium is threaded with coherent structures, possibly shaped by ancient processes or intelligences. Similarly, the search for technosignatures, evidence of advanced civilizations, has gained momentum, with initiatives like the Breakthrough Listen project scanning the skies for non-natural signals. Voyager 1's findings align with these efforts, offering tantalizing clues that the galaxy may be more organized and perhaps more inhabited than we previously thought. Ethical and philosophical implications. The possibility that Voyager 1 has encountered an engineered system or intentional signal raises profound ethical and philosophical questions. If the golden record has triggered a response, have we inadvertently exposed Earth to scrutiny or risk? Should we attempt to decode the pulses, knowing that doing so might confirm our presence to an unknown entity? These questions echo debates within the SETI, Search for Extraterrestrial Intelligence community, where scientists grapple with the risks of active messaging versus passive listening. Voyager 1, by broadcasting the golden record, may have already made that choice for us. Moreover, the architect hypothesis challenges our anthropocentric view of the universe. If the galaxy contains engineered zones, humanity may be a latecomer to a cosmic stage, our technology primitive compared to systems that have operated for billions of years. This perspective invites humility and caution, urging us to approach Voyager's discoveries with both curiosity and restraint. As we analyze the spacecraft's data, we must consider not only what we hope to learn, but also what we are prepared to confront. The future of Voyager 1 and beyond. As of May 16, 2025, Voyager 1 continues to transmit data, though its power supply is nearing exhaustion. NASA engineers estimate that by 2026, the spacecraft's instruments will cease functioning, ending its historic mission. Until then, scientists are racing to interpret its telemetry, using advanced algorithms to extract meaning from the structured pulses and magnetic anomalies. Collaborative efforts, involving institutions like the Jet Propulsion Laboratory and international research teams, are underway to cross-reference Voyager's data with observations from other missions, such as the Interstellar Boundary Explorer, IBEX. Looking ahead, Voyager 1's discoveries underscore the need for new missions to explore the heliopause and interstellar medium. Proposals for next-generation interstellar probes, equipped with modern sensors and propulsion systems, are gaining traction. These missions could confirm whether the anomalies detected by Voyager 1 are isolated or part of a larger phenomenon. Additionally, advancements in quantum communication and artificial intelligence may enable us to decode signals that Voyager's outdated instruments can only hint at. Conclusion: a whisper that echoes across time. Voyager 1, a relic of humanity's ambition, has drifted through the cosmos for nearly half a century, carrying our story to the stars. Now, at the edge of the solar system, it has encountered something extraordinary, a structured signal, a cosmic whisper that challenges our assumptions about the universe. Whether this is a natural phenomenon, an ancient mechanism, or an intentional broadcast, Voyager 1 has touched the unknown, not with a satellite, but with a question. Are we alone, or have we simply been unaware of a galaxy that is watching? The structured pulses, magnetic ripples, and telemetry distortions detected by Voyager are more than scientific curiosities. They are a call to reimagine our place in the cosmos. As we stand on the brink of this discovery, we must confront the possibility that the greatest revelation of our time will not be what we have seen, but what has already seen us. Voyager 1, once a scout, may now be a herald, its faint signals marking the moment when humanity first heard the universe speak back.